the project I'm going to be covering is actually called the Canada, France, Hawaii Telescope. This is a telescope that sits in Hawaii, and its main objective is to take high-resolution images, essentially, of the sky. Now, why am I talking about this today? This telescope was originally commissioned in 1979, and over the years, over the 4 decades, technology has increased greatly. So what we're going to be doing for the next 40 minutes is we're going to be retrofitting new technology on top of the existing technology of this telescope. And we're going to be doing this using the suite of SOLIDWORKS 2019 tools. So what you're seeing on my screen right here on the bottom half is the existing telescope that was originally commissioned in '79. And what I'm going to be going through using the 2019 tools is the top half of this telescope. And I'm going to be showing you how we accomplish this using all of the tools in SOLIDWORKS. So the challenges that we're going to have involved in working with something like this is we have some legacy data, right? It's obviously a very large design, so there's going to be a lot of new design. So we're going to talk about managing legacy data and new data together. And most importantly, this is a huge assembly. It's over 100,000 components. As we get going inside large design, hopefully you're using a vaulting tool like SOLIDWORKS PDM. There's 2 flavors of PDM, PDM Standard or PDM Pro. If you're not familiar with PDM, PDM is your file management tool. You can think of it as your checking account. It's what manages your cache. But there's a lot of things that need to get managed outside of just files, like databases, purchasing information, manufacturing information, tooling. All of these things sometimes get forgotten. And that's why I want to introduce a brand new tool to you called SOLIDWORKS Manage. So here's my personal manage environment. And what you're going to see right now is the dashboard. Here's the reporting that you're going to see. Now, one thing to keep in the back of your mind of Manage is it sits on top of PDM. So PDM is kind of like a prerequisite to Manage. In here, you're seeing my personal tasks that have been assigned to me. Along with that, you're seeing my team tasks and the progress of these tasks. Down here, you're seeing projects, and you're seeing myself track my projects by month. So I now have a clear understanding of what's going on. The really neat thing of this is I can plug this into PDM, I can plug it to ERP, MRP, I can query information out of other databases and now track it all in one central interface. The second thing I want to show to you is managing physical documents sometimes go into the project, so you'll notice that my manage environment is sitting on top of PDM. So those 2 things interact together. The third thing I want to show you is my processes. These are processes that are outside of my engineering realm. For example, when a new project for a production comes in, before engineering actually starts doing something, some key things have to be checked off on my business, and you're seeing that workflow or that process down here on the bottom of my screen. In my case, the quoting needs to look at it, the project manager gets assigned, he looks at the project, he's going to own it, and then our engineering manager looks at it and says, hey, yeah, this is capable, we could probably engineer this, and then it goes and it gets assigned to an actual engineering team. The last thing that I want to show you is my projects, and you'll see that I actually set up a project for today, and I have 3 tasks that I'm going to cover over the next 30 minutes that correspond to that telescope. And as I finish these tasks, I'll come over here, mark them as complete, and you'll start seeing my slider bar for that project go on. And the benefit of that is it's helping my downstream people know where the engineering team is at in this specific project. With that said, before I get into SOLIDWORKS, I do want to talk a little bit more about performance. Now, what you're seeing is you're seeing right now in real time that 100,000 component assembly open in SOLIDWORKS 2018. You'll notice that when you work with the large assembly, zooming in, zooming out, rotating around, hiding things, doing all those kinds of functions when you're just manipulating the stream can be a little clunky. And it's kind of a simple equation. It's hardware related and software related. You're just processing a lot of data on the screen. What you're going to see in SOLIDWORKS 2019 is doing those same functions by nothing else that you have to do yourself. It's just going to be snappier. We're taking advantage of a lot of enhancements in hardware, and we're matching the software to go with that. Here you're seeing the 2 installs, 2018, 2019, side by side, so that way you can know I'm not lying to you. And you can see doing the same actions in SOLIDWORKS 2019, it's just snappier. Again, nothing that you specifically have to do. I just want to call to everybody here that we're taking advantage of a lot of hardware enhancements in SOLIDWORKS 2019. Let's go ahead and dig into SOLIDWORKS, and let's look at some of the functionality. Now, the first thing that you're going to notice is last year we added this home screen where we've built on this. If you go to your recent documents can now show up to 100 of your recent documents. So instead of limited to 16, you can see your 100 most recent documents. On top of that, there's the quick filter, which is the same quick filter from the open command. So if I was looking for recent documents that were just parts, I can click on the part icon and it'll filter out my 100 most recent part files that I've opened. If you're like me, a lot of times I'm looking for something very specific. I open up a lot of files, so you can now take advantage of the filter. So if you type in any character, it'll filter out your recent documents, finding those. And if you're really like me and you get anal about your recent documents, if there's things that don't want anymore, on the far right of that, you can get rid of unpinned items by saying remove unpinned items. So anything that you haven't pinned in there, it'll go ahead and remove from that recent documents, cleaning up that list. Now, some of my favorite things they add are just the little things. So over here, if I go to options and I come down here to file locations, you'll see we added a new file location for those people who have their favorite save folder. You can now tell SOLIDWORKS, hey, when I hit save, always just go to this folder every single time. I don't care what I'm saving. Which for me just saves me a lot of time because I save all my junk in a junk folder. Now, when you're working on complex designs, a lot of the time we create what we call external references. If you don't know what an external reference is, let me kind of just outline that. An external reference is when you create a reference between one part, say a dimension, to another part that's different. Now when you change part 2, it's going to change part 1. The problem with that, it's really not a problem, the challenge with that is managing those references. Well, one thing that we did to make managing these references even more efficient is if you click on a sketch or a feature or a part that has an external reference, you'll see this new dynamic visualization tool. So in this case, it's showing me that that sketch has an external reference to that part down there called front cell. Now, if you want to prevent somebody from messing up one of your external references, from this visualization tool, if you click on that node, when you click on that node, you can tell it to lock a reference directly from the feature tree now. Another way that you can see that is if you right-click on the tree and you use the option called External References, it'll show you a tabulated view of all external references for that part or that assembly. The cool thing about that is if I'm going to pan this over to the right so you can see both, is if I come down here and I find one of these external references, for example, this pattern, if I right-click on it and choose Isolate, it'll isolate that assembly, showing me the reference from that part to the other part. So now I don't have to guess at what the part looks like or what it's referencing to. So it just makes it easier to visualize these references. On top of that, if I click on it and I choose Break Selected, I can now break that reference directly from this tabulated view. And what you'll notice is it doesn't screw up my feature tree. It gives me the ability to go back and now replace that reference with something new. Now, one thing that I really like about this is, like most things when we're looking in a list view, I can actually filter this out. So if I'm looking for only broken references, I can uncheck mark all the other options, and now I can only see my broken reference. Now that I've broken that, we obviously probably want to fix this. So what I'm going to do is I'm going to go ahead and isolate this component. I'm going to close down my external reference. There's my pattern. We'll edit that pattern. What you're going to see in SOLIDWORKS 2019 when you edit broken references, instead of throwing you an error or a warning, it's going to let you very intuitively just go choose a brand new reference without toggling through 100 different screens. In this example, I'm going to go ahead and choose a new circular face to reference for that circular pattern. We'll hit Exit Isolate, and we'll go ahead and confirm our change. So managing external references has never been easier. Now, I need to do a few more design changes while I'm in here. So what I'm going to do is I'm going to leverage a 3D view. So I just have a bunch of parts hidden. And I need to come in here and I need to modify or tweak the design of this plate. So that way there's 50 millimeters between those two faces. So I come in here and I modify this and I think to myself, man, I don't really know what that number should be. So what you'll notice in SOLIDWORKS 2019 is when you are in any feature, you can now access the measure command without getting out of the feature. So in this example, I'm going to say, okay, that's supposed to be 50 millimeters. So what is it really? Okay, I don't want to get out of my dimension command, so I can say, oh, it's really 45. So instead of getting out of here, I can now just say, okay, that's really supposed to be 5 millimeter. I can come over here, click 5 millimeter, hit enter, and I'm off to the races. So again, it's a little thing, but those are those little things that just kind of make your life a lot more enjoyable. For those of you guys that know me personally, know I used to run a manufacturing facility, and one of the biggest things that I was after was the minimum amount of material. They'd say, Roland, we need pricing for all this, can you quote it? Ooh. So how do we figure out the minimum amount of material? We call that a bounding box. A bounding box, if you don't know what that is the minimum X, Y, and Z. Now in sheet metal and in weldments, bounding box, it automatically gets generated. For something that's not sheet metal and not a weldment, you can now generate a bounding box by going to reference geometry, choosing bounding box. You have some nice options. My favorite one is best fit. I hit the green check mark, and now it gives me the minimum X, Y, and Z. The cool thing about this is I've been leveraging this in my SOLIDWORKS drawings as notes. So by turning that on, not only does it tell you what the bounding box is, it creates a custom property that shows you the minimum X, the minimum Y, the minimum Z, and the minimum volume. Now, if you're a savvy old veteran like me, the way that you cheat that before 2019 is you turn on the weldment command, see what the bounding box is, and then turn weldments back off. And it's kind of cheating. Now you can just do it without having to do anything special. Now, we wrapped up this design, so we need to go ahead and update the drawings and do some modifications. Now, I used to create a lot of drawing views that we called slice sections. You're going to see a brand new tool called remove section. The way remove section works is now all you have to do is choose two edges. Whether they're parallel or at an angle, it doesn't matter. And then instead of creating a bunch of reference geometry to control this section, you can now come in here and snap to, say, there, and maybe I want to snap this to the endpoint. And in real time, without doing anything fancy, I now have a slice section. So we've made creating slice sections even faster and more efficient than ever before. On top of that, I'm preparing this drawing for manufacturing, so I want to give my CNC machinist all the whole information for this view. One common way to do that is to use what we call a hole table. Now what we've added now is as you create a hole table, I'm going to choose an origin and choose a face. Once I place this hole table, I can now dictate the XY location either by, my favorite is reduce toolpath. So that's going to show hole A, and then it's going to find the next closest hole to it, hole B, give it a name, and give it the XYZ from the origin. Find the next hole, same thing. So for those of you guys that are setting up drawings for machinists, this could really save you a lot of time. You're not having to manually rotate those around. Another option is to choose radial. So it'll essentially start going in XY coordinate system from the origin and start labeling them radially around that. On top of that, one of the most common questions I get in hole tables is, hey Roland, I want to change my tags. How do I change my tags efficiently? You'll see in here I can now just simply choose a manual tag, and I can just overwrite the system by clicking in a cell and typing in anything for my tag number. So for example, I might say AA01 and say B01. We're going to combine the same sizes. We'll hit this green check mark, and you'll notice that it automatically updates that tag number. Old school way is you'd have to go click on that, and then if you changed holes, add holes, it wouldn't re-associate, and you have to do it over and over. On top of that, if you right-click on any one of these cells, you can choose the option called Assign Tag Prefix, and you can just do this on the fly. So for example, I might want to change that tag to K1. Now, how many of you guys have ever opened up a drawing that had a lot of stuff going on it? A lot of dimensions, a lot of views, large assembly, and it's just slow. The challenge with that is sometimes we'll do a lot of design changes, and every time we get back into the drawing, it has to do what? To refresh the views. Okay, rebuild. Now, one thing that I want to show you is you can now essentially pause the rebuild. So if I click on any view, in this case I'm going to choose these two views, I'm going to tell SOLIDWORKS to exclude from rebuilding. You're probably thinking to yourself, why the heck would you want to do that? The benefit for that is when you're doing a lot of design changes and you're toggling back between the drawing and the assembly, we might not want to rebuild everything. We might only be concerned with one view at a time. So instead of letting SOLIDWORKS go and rebuild all the views and taking 45 seconds, now you can say, you know what, exclude all these other ones, just rebuild the one view I'm concerned with right now. It'll only take a few seconds. And then when you're done with the project, you can say, all right, go ahead and finish rebuilding all the rest of the views. So what does that look like? You simply choose a view, and you tell it over here from the options to exclude from rebuild. Now I'm going to go ahead and make a design change so you can see what's going to happen when you get back into the drawing. In this example, I'm going to open up this part. I'm going to come down here. I'm going to change that 7 millimeters to 11 millimeters. We'll rebuild this. We'll go back to our drawing. you'll notice that this view up here at the top, I did not tell it to exclude, so you'll notice that that face got fatter, just like I told it. All these other views that I told it to not rebuild is going to get the old school little orange stippling, letting you know that that view is what? Out of date. So the easiest way to now tell it to go ahead and update that is right click on the view. You'll see the old school little stoplight icon called update view. I'll tell SOLIDWORKS to update it. So what am I saying here? What am I not saying here? What I'm not telling you is go tell SOLIDWORKS not to rebuild any views. That's not what I'm saying. What I'm trying to tell you is when you're working with large assemblies and complex drawings, sometimes we don't need to rebuild every view every single time, and this is a way to take advantage of that and now work a little bit more efficiently when you're working on these large designs. How many of you guys have ever sent a bill of material to somebody who's non-technical? One of the most common questions when I do that is, Roland, I'm looking at this BOM, but what do these parts look like? Anybody ever come to you? They show you bill of material, like, hey, I'm trying to find this part. What does it look like? Watch this. If you put your cursor on a bill of material inside SOLIDWORKS, what happens is, I'm going to zoom in so you guys can see this real nice and big. A preview pops up. You're like, okay, I have SOLIDWORKS. I can open it up. So what? Check this out. I want to share this with my downstream feature, my downstream people. I'm going to right click on this bill of material. I'm going to choose Save As. I'm going to change the type to Excel because they don't have SOLIDWORKS. So they need to see this BOM. I need to give it to them something other than SOLIDWORKS. Here's the kicker. Everybody see this right here? What does that say? Thumbnails. When I check mark that bad boy on and I hit enter, watch this. Bill of material with previews on it. Like, all right, dude, you want to see what this part looks like? Go open up Excel. Here you go. So now you can take thumbnail previews, put them in a bill of material, and save them out, and now those downstream people don't need to pester you, and they can leave you to do your engineering, and they can look at a bill of material and see what those physical parts actually look like. In here, I have the add-in called inspection on, so I'm going to tell it to create a new inspection report. Essentially, this is what the quality guy would be doing, or possibly the engineer for the quality person. Now, there's two flavors of the quality tool. You can run it as an add-in. So if you're a SOLIDWORKS user, you're probably going to run inspection as a add-in. If you're using stuff that's not SOLIDWORKS, that's okay. The inspection standalone tool can handle TIFFs, dumb PDF files, and other CAD documents. So you can create the same thing whether you're using SOLIDWORKS or using something that's not SOLIDWORKS. Now, one of the new things that we've added in here is the ability to link to custom properties. So for example, one of the things I want my quality person to check is I want them to check off their name that they're the person that approved this. So I'm going to add a custom property called check by. I also want to make sure that they check the material. So I'm going to add another custom property in this report linking to the material of the actual model. So we're building a lot of intelligence into the inspection report as opposed to just typing out an Excel file that has no knowledge in there. We change something and somebody has to know and go update that. It's a very error-prone process, believe it or not. Side note, I've physically done this in real life and it's not fun. So if you're doing this, you probably know the struggle. Once I'm in here and I'm done setting up all the parameters that are not dimensions, I hit the green check mark, and in the background, SOLIDWORKS is going to do this real fancy thing, and it's just creating a bunch of red balloons. These red balloons, we call them characteristics. Essentially, all that means is that's something the quality person is actually going to go and measure. What's new in the inspection tool in 2019 is not only will it go and put characteristics on all the dimensions or GD&T callouts, it will actually go put characteristic numbers on tabulated tables, like my whole table. So now my quality expert can go look at each row and make sure they check mark that off in the report. On top of that, we make it really simple to modify this. So for example, I'm going to come down here to this tapped hole. I have one character number, 18, but that hole's a quantity of 2. It's a pitch of 2.5 millimeter down to a depth of 5 millimeter. Well, the quality guy really needs to measure each one of those as a discrete, hey, yeah, that is good. The pitch is good. The depth is good. There's 2 holes there. So inspection gives you a lot of good control to modify these reports. The neat thing about it is they're intelligent. So as you make design changes, you don't have to go and do the same actions over and over. In this example, I'm going to take the character called 18, and I'm going to say ungroup it. And what it's going to go do, it's going to go grab those holes, it's going to count them up, and now it's going to put a character balloon for each measurable parameter that the quality guy would need to actually inspect. So again, we're just automating that process of distributing this technical data to somebody who might not be as technical. The cool thing about it is I can modify this by just simply dragging and dropping, so I can even make it more foolproof for the quality inspector. Now for me, I want to label all these as what we call sub-characters. So instead of each getting them a hard character, I want to label them 18.1, 18.2, and so forth. So I'm going to highlight them again, and I'm going to say group them back together, but this time group them together in a sub-character. If you're thinking to yourself right now, man, that's really neat, why aren't we using that? Come find me afterwards, and I can get you more information. This is an add-in tool, so this tool would be supplementary to your current SOLIDWORKS installation. This is not a tool that comes with SOLIDWORKS just by itself. It's called SOLIDWORKS Inspection. Once I'm done with this, how do we publish this and how do we link it up to a CMM machine? All we have to do is come up here and choose Export to 2D PDF, which creates the bubbled balloon, and or Export Excel, which creates the Excel document. Or if you wanted to link it to a CMM, that's where we would export this as an inspection report, and we would format that to format with your CMM machine. Now I want to get back into Manage for a second. Manage is conjunction with PDM, okay? When I'm done with this, I want to submit a workflow. So in here, I'm going to come over here to the right-hand side, and I'm going to right-click on this panel, and I'm going to say Change State, Submit for Approval. Or, in my case, I like to go rogue, and I just approve my own work, right? I don't need somebody reviewing my stuff. I'm ready to go. So when I hit Approved, there's two things that I want to point out. The first thing is in the background, this is actually triggering my Manage process. So Manage and PDM go together. For those of you guys that are using PDM currently and have interest in Manage, the benefit for you is your users aren't going to have to start back from square one learning a brand new tool. They're going to be learning supplementary tools. The second benefit is Manage runs on top of PDM, so it's going to have the same interface on the right-hand side of your screen. Now, what I really want to show you, what's new, is if you're a sheet metal guy like me, right, I need DXFs to program off of. Now, via SOLIDWORKS PDM, I can auto-generate via a workflow in this case. So Jeremy earlier showed you a manual task. I'm actually triggering a workflow of the flat pattern DXF using my SOLIDWORKS PDM vault. So I don't have to go open up that thing and right click on it and say export DXF, do this, do that. Anytime I approve a sheet metal part, a DXF will now spit out, and in my case I'm putting it in my manufacturing folder. So that's brand new for PDM 2019. Now let's dig back over here to my Manage interface, and I'm done with my first task. So I want to show everybody in my organization I've completed my task, whether that is a SOLIDWORKS model, an analysis, or anything for that matter. So it's pretty simple to use Manage. Most of your functions, most of your actions are going to be via a right click. In this case, I'm going to mark this as completed. It's going to warn me once I complete it, I'm good. You'll see my slider bar go from 0% to 100%. A notification goes out to my boss letting him know task 1 for my Dallas, East Texas rollout is now complete. We're ready to go on to task 2 or whatever the next trigger might be in the workflow. Now, let's get back over to SOLIDWORKS. Let's go to task number 2. So we're going to be done with that panel. Let's get into an assembly. Now earlier Jeremy showed you how to mark things up. Now one thing that you can do is using that same functionality is, in this case, I'm just going to go ahead and draw on my screen. I'm going to say take all that stuff and explode it. Now I want to take that functionality that Jeremy showed you earlier and take it one step further. In here you'll notice I can actually rename these markups. So I'm going to call this Rollins markup. And you can export these by simply right clicking and choosing export markup. So what's the benefit of this, or why am I even showing it to you? What I like to do is on my screen, I create markups, I then export them, and I send them downstream to people that don't have SOLIDWORKS so they can review what I've been doing and what I'm looking at. So again, half the battle sometimes is just sharing your technical data, and we don't want to buy SOLIDWORKS for everybody, right? So this is another way that we can do that. The neat thing is once you're done with these markups, you can just take all these guys. In my case, I'm going to highlight them all by holding shift, and I'm just going to hide all my markups, that way they're not confusing. Now, I like to start at the end. So what I'm going to show you here is I need to create an animation for my manufacturing team. I want to show them how to do the maintenance on this actual hoist that goes into the telescope. Sometimes creating drawings just doesn't give us enough information, so we have to create an exploded animation in SOLIDWORKS, which we've been able to do this for quite some time. What's new is we made it even easier to modify, manage, and seeing what's going on with an exploded view. So first thing I want to show you is if I come over here to my configuration manager, you'll see there's my exploded view. Nothing new there. I'm going to right click on it. I'm going to choose explode. Now here is what's new. Is if you look at the bottom of that exploded view, you're going to see this little blue bar. Does anybody know what this is called? Rollback bar. Yeah, we got some veterans in the house. You can now leverage the rollback bar in the exploded view without actually editing the exploded view. You just grab that bar, you drag it up to the top, and now I can come down here one at a time and I can see how the person actually exploded this. In this case, I notice as I come down, you'll see that those screws right there are out of order. Does everybody see those screws? So how can we fix this? You can come over here without actually editing that exploded view, and you can grab any exploded step and just reorder them by dragging. On top of that, if I take this rollback bar and I drag it down, and then I edit exploded view, okay, so watch this. I want you to make note where that rollback bar is. It's 3 from the bottom. If I actually edit this exploded view, you'll see that rollback bar is actually live while you're editing an exploded view also, so it keeps that knowledge in there. Now what I want to point out to you is if we come in here and we go to that left view, I actually need to create a new step. So one benefit of using that rollback bar is when I roll it in place, I can now create a new step, and it's going to add that step to wherever that rollback bar is. So now I can go and fix animations, reorder them, and organize them a lot more efficiently. On top of that, naming exploded views has become even easier. All you have to do is click on the exploded view and give it a new name. Roland's washers. Don't mess with them. I don't have to do anything else. I click off the screen and I'm ready to roll. When I hit the green check mark, you'll see my rollback bar stays exactly where I left it, so now I can keep on editing. Now one thing that I'm really liking is when I'm in this exploded view, I'm going to roll this bar to the end. I can come in here and I can suppress states, which I wasn't able to do before. So maybe you want to manipulate how, a phase, like, hey, here's step 1, here's step 2, here's step 3. You can now suppress those exploded steps directly from the configuration manager. For me, I no longer need these, so I'm going to highlight them all, and you can actually also delete steps from the exploded view. Now, how many of you guys have ever exported out an animation from SOLIDWORKS? Anybody ever done that? And does anybody know what file type it would export out as? AVI. What we've added now is when you go to the save command, we've added more options in the export of your animation. So AVI is the traditional one. We now added FLV for flash video, MKV, or my personal favorite, MP4. So we've added more options for exporting those animations out. Again, it's one of those little things, but we're just giving you more options so that way you can share this data with people outside of the engineering team. People say, man, I've got this part, it's got a lot of features, surely it's making my system slow, right? That's not necessarily true. What slows down a large assembly is the amount of faces and the amount of edges on the parts that are in that assembly. For example, if we look at this winch right here, we can see that they put the logo in there. And although it looks cool, it's really going to kill your performance when you put this in a large assembly. Same thing for this perforated holes, for all those ribs, for the fins on this motor. So what can we do to make that more efficient? I'm going to show you a tool called Defeature. Now, Defeature isn't necessarily a new tool, but the options that we've added in Defeature make this very simple and way more efficient than ever before. What you're going to see is you'll see a second button down here, and we call this a silhouette. I'm going to hit next, and I'm going to start telling SOLIDWORKS to create me a part file using this assembly as the parent, but I'm going to tell SOLIDWORKS to start simplifying it, pulling out some of the things that I don't need. In this example, there's some geometry I don't want to mess with. For example, this end cap, the body of the winch, the cable, and the 2 mounting brackets, I don't want those to be simplified. I want them to look exactly how they are. So what I'm going to do is I'm going to highlight them, and I'm going to tell SOLIDWORKS to not do anything for them. When I hit OK there, it's going to show me a preview, which is essentially the part that I'm creating from this assembly. This is the simplified part. So in real time, as I manipulate this and defeature it, it's showing me what I'm after. The idea, the concept is to create a representation of this so that way it works more efficiently in a large assembly. The next thing that you're going to see is I'm going to say this little hub. I'm going to say the little motor over here. Now, one thing that we've added is if you come over here and you right click on a component, you're going to see an option called select identical components. In this case, I want to grab all 4 of those little bearings. So I just right click on them, say select identical, and it grabs all 4 of them. On top of that, I want to grab all 4 of these little pieces of all thread. And we'll say, yeah, that looks good. And what I'm going to tell SOLIDWORKS to do is create a cylindrical representation of those components. So I tell it to switch it from none to cylindrical, and now you're going to see my preview update, and instead of having all that detailed feature, it's just going to put a cylindrical boss there. Now on top of that, there's a few other things I want to do here. In this example, I want to take this little control box. Maybe I want to go and select these 2 nuts right here. And these mounting pieces of hardware. Whoops. And this time, instead of doing it as a cylinder, I'm going to tell it to create a polygonal outline. So for example, on those nuts, it's going to get rid of all those little cutouts and all the chamfers and fillets, and it's now going to create a simplified version of that nut. We call that a polygon outline. Now let's take this one step further. There's a few other things I want to represent. In this case, I want to grab that little motor right there. And I don't want it to be a cylinder or polygon. I want it to create a piece of geometry that kind of fits tight around that. So I'm going to tell this time to choose tight fit. I'm going to add a group. And instead of creating just a simplified polygon, it's going to create a piece of geometry that closely resembles that. Once I'm done, I'm going to hit next. I like to tell it to save it as a new document. I'm going to tell it to link it to the original so I can know where it came from. I simply hit save. I'm going to replace my existing one. And then I'm off to the races. All right, so we've got that done. We're going to come back over here into Manage. Task number 2 is complete. So I'm going to right click on it, mark as completed, hit yes. Now on to task number 3. If you come over here and you look at the mates list, great. When we have large assemblies, finding the stuff that's messed up or hosed up can be a challenge. What you're going to see in SOLIDWORKS 2019 is when you right click on the mates list, and you're going to see an option called group by status. Okay, let me show you what that does. Instead of seeing a big laundry list of mates, it now groups them. What that does for you is it gives you better insight of what's going on when you have some boo-boos. And sometimes this stuff is unavoidable, right? It happens to me too, believe it or not. In this case, I can see that that mate is missing a reference. So it's a pretty simple fix. It looks like I could probably just re-reference it to this new face. Now watch this. I love this. When I hit this green check mark, what it's going to do is it's going to say, if there's any other mate that is hosed up, that is missing the same reference as this one, do you want to just fix them all? Well, absolutely. I don't want to go fix all those mates. So I'm going to say yes, replace all missing mates that were missing that face. And now when I confirm out of here, you'll see that that Jeremy's folder is gone. All right, so the error folder is no longer there. What about this folder called overdefined? If I grab these 2 mates down here, I'm going to suppress them. They're the overdefining mates, FYI. You'll see that it takes the other 2 that are now solvable, and it puts them in the solved folder, and it creates a new folder called suppressed. Now, I don't really need suppressed or missing or mates to things that are already fixed. So I'm going to highlight all those guys, and now I can just say, yup, get rid of them all. And now my mates folder is one clean, which is usually the goal. You've got one clean folder in here that says all your mates are solved. So we're just making it a lot easier for you to go in there and fix and group those things more efficiently. This is the structure that's holding that new telescope. So how many of you guys use weldments? Anybody use weldments in here? Man, I love weldments. Multi-body modeling and weldments is one and the same thing. I'm going to show you a brand new tool, brand new to 2019. It's called the structure tool. So if I was going to create this without using 2019, I would probably have to do a lot of 3D sketching and or 2D sketches with a bunch of reference planes. True statement, okay? What I want to show you is how to create this in a fraction of the time with a fraction of the geometry. So what I've done here is I took a sketch, it's 2 hexagons, and I extruded it as a surface. So I got 2 hexagonal surfaces sitting inside each other. Everybody cool with that? 2 hexagon surfaces, that's all that is. What the structure system gives you the ability to do is instead of drawing lines, you can apply a weldment body on any edge of a plane, edge of a surface, line, between 2 points, between reference planes that intersect, and it'll treat it as a sketch, and it'll put a body on there. Let me show you how that works. So there's a brand new tab called the Structure System. When I click on Structure System, I'm going to turn that environment on. It is a subset of your weldment tools. Then I'm going to come in here and I'm going to say, let's go ahead and create some weldment profiles. Now, before I start selecting things, just like in weldments, I'm going to tell it what I actually want to use. In this case, I have a custom library called CFHT Structures. I want to use square tubing, and I want the square tubing to be 10 inch by 10 inch with 1/2 inch wall. Is everybody with me so far? 10 inch square, 1/2 inch wall thickness. Now, I'm going to come back over here, and I'm going to box select. I'm just going to drag all of those surfaces. What it does, it says, oh, this is a surface. It grabs the edge of the surface, and it puts the member on the edge of it. So guess what I did not have to do? I did not have to create a bunch of 3D sketches or 2D sketches or reference planes. I just extruded 2 hexagonal surfaces. Okay, not done there yet. This is like one of those infomercials. And wait, there's more. All right? Okay, so you say, okay, Roland, that's cool, but those vertical members, I don't want them to be squares. I want them to be round tubing. Like, okay, I got you. Now, just so you can see this better, I'm going to hide my original surface bodies. I'm only doing that so you can see what I'm clicking. And I'm going to box select all those vertical members. When I select them, I'm in that structure environment. It says, okay, Roland, you selected those. What do you want to do with them? In this case, I'm going to tell it I want to change those from square to round, and I want them to be 10 OD with a 3/8 inch wall thickness, and then I'm going to hit the green check mark, and now it took all those members and it made them from a square member to a round member. Now, most of you guys usually root against me. You like to see the technical guys fail or crash the software, so you're probably like, aha, I got it. You can't manufacture that. That looks ridiculous. And I would agree with you. I wouldn't make that. So we're going to come and we're going to see how we can manage those miter cuts more efficiently. But before we do that, I know, maybe I did an analysis on this, and I say, you know what? I need some horizontal members intersecting all of this around to give this some more rigidity. So we call that a secondary member. Now, there's a few different ways. The most common way to create a secondary member in the structure environment is use the intersection of a plane and an existing weldment body. Okay, so let me show you what I'm talking about here. I'm going to go to the front view. You see the top plane? The top plane intersects my body about 2 foot from the bottom of this. I'm going to select it. We're going to come back to that. Plane number 3, it intersects that structure 2 foot from the top of the structure. I'm going to select it. Now, here's where the magic happens. On that plane, it's now going to start putting members between members that I've selected. So watch this. I'm going to click this vertical member, and I'm going to click that vertical member. And where that plane intersects those 2 vertical members, it snaps in a new round tube, and it copes it around the existing one. That's where you should start clapping. Be like, yeah. Okay? Now, not done there, right? I'm going to keep on clicking. So I'm going to come over here, I'm going to click these 2, I'm going to click these 2, and now instead of, okay, I've done this before in real life using the normal weldment tool. You would have to go and create a 3D sketch or a 2D sketch or a plane and draw lines. And then you'd go weldment, structural body, click, 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 trim, 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 hit the green check mark. All that's gone. I hit this green check mark, and there it is. What would happen if I moved that plane up or down? What would happen to those bodies? They're going to move with it. Everybody see where I'm going? Okay, now, let's go back to this mitered corner. You're like, all right, this is where we're going to see Roland fail. Hopefully not. rooting for myself here. So how do I fix that? When you get out of the structure environment, it's going to go into the corner management tool, right? In that corner management tool is where we can dictate, right, where we can dictate these corners. Now, I'm not going to do them all. You can do this globally, or you can do one at a time. I'm going to show you how to modify these one at a time. So, for example, I'm going to click on this first vertice. What happens is it groups these guys together. So there's your 3 members. If you leave them all as what we call trim order 1, it's going to trim them, coping them all as a miter, all trying to put them together, which is not what I want. I want that round member to be flush with the bottom face of the square. Is everybody with me? So that way I can actually weld it. So I'm going to find that member, and I'm going to say, no, I don't want you to trim 1. I want you to trim it second. I move it down, and now it miters the other 2 to each other, and that bottom flat one is cut flush to the first 2. Now you say, well, Roland, what if I don't want that mitered? We call that an in-butt. I want to butt one up to the other. You'd grab one and you'd move it up. And instead of doing a miter, if I could click here, instead of doing a miter turn, clicking on the wrong button, right? It's going to do a in-butt, where it's not going to create a miter, it's going to butt one up to the other, so it extends that out. If you wanted the reverse of that, you would do the exact same thing, but you'd select the other one and move it up. In this case, I want that to be mitered. I hit this green check mark. As soon as I hit that green check mark, it goes in there and it miters that, and now I have my clean weldment profile. Now, one other thing I do want to show you is you can use the structure system not just for planes and other bodies. You can still use sketches. So for example, I have this little zigzag sketch. If I come in here and I select these bodies, I can still come in here and create your traditional body structures just the same as you're used to. So no different there, right? Now to wrap this up, so as we get out of here, I want to go back into Manage, and my last task is now complete. So I'm going to right-click on it, mark as completed. I'm done with the project, and I'm off to the races to do the next project. So where are we at? What I hope you guys take away from both Jeremy and I's presentation is using the SOLIDWORKS 2019 suite of tools and using PDM and Manage. We hope that you can keep real-time insight to what you have going on using SOLIDWORKS Manage. Hopefully you're using the tools and staying ahead of schedule with PDM. We like to think that you're able to collaborate and communicate a little bit better using tools like 3D markup, using e-drawings. I love the HTML. And then fourth, and most importantly, we're able to kind of repeat the same processes.